Okay, let's look at this application. This can be found in your guide. So you can find this on pages D1 to D3. So we'll just walk through this question. So we have a job offer. We're looking to get a job at an arena, and you will be selling hot dogs at the canteen. So you can have 3 different wages. The first offer, you could just get $10 per hour. So regardless of how many hours you work, you're going to get $10 each hour. The second offer is that you could just make money by selling hot dogs. So you wouldn't get a salary per hour, but you would get commission, meaning that you're going to get paid 50 cents for every hot dog that you sell. And then the third offer is a combination of the two, where you will get $5 an hour, plus you would get 25 cents for every hot dog that you sell. So we want to figure out which pay schedule would we like to pick and why. So we could start by making a table of values for each offer. This is just a table for 1 hour, so how much I would make in 1 hour. And this is going to depend on how many hot dogs I sell in that hour. So offer A, where I'm getting $10 per hour, it doesn't matter how many hot dogs I sell. I could sell 0 hot dogs and still get $10 for that hour. I could sell 2 hot dogs, I'll still get $10, and so on. So I'm going to get $10 regardless of how many hot dogs I sell. So I'll go all the way up to 10. Even if I sold 20 hot dogs, I'd make $10. I could sell 40 hot dogs, I'll still make $10. Okay. In offer B, we get 50 cents per hot dog. So we don't get an hourly wage, but we get money for selling the hot dogs. So if I sell 0 hot dogs, I'm going to make $0. If I sell 2 hot dogs, I get 50 cents per hot dog, so that's $1. If I sell 4 hot dogs at 50 cents, that's $2. If I sell 6 hot dogs, I get 50 cents per hot dog, that's $3. 8 hot dogs would be $4, 10 would be $5. If I sold 20 hot dogs, I'd make $10, 20 times 50 cents. If I sold 40 hot dogs, I'd make $20, 40 hot dogs times 50 cents. And then the third offer is $5 an hour plus a quarter for each hot dog. So if I sell 0 hot dogs in that hour, I still make $5. If I sell 2 hot dogs times a quarter is 50 cents plus the $5. So $5.50. If I sell 4 hot dogs for a quarter each, that's $1 plus the $5 is $6. 6 hot dogs would be an extra $1.50 or 50 cents, so it would be $6.50 plus the $5. So 8, 10, and then let's go up to 20 and 40. So 8 hot dogs times a quarter is $2 plus the 5 is 7. 10 hot dogs times a quarter is $2.50 plus 5 is $7.50. 20 hot dogs at a quarter each is an extra $5 plus the $5 per hour, that's $10. And 40 hot dogs times a quarter is $10 plus the $5 is $15. So that is a table of value for each. The question is, how much money would we make if we sold 40 hot dogs? Well, that will depend on our salary. In offer C, I would make $15 for that hour. In offer B, I would make $20 for that hour. And in offer A, I would make $40 for that hour. So the other thing I can see in the table is that when I sell 20 hot dogs, I make $10 for each offer. So 20 hot dogs seems to be the point at which all offers make the same amount of money when selling 20 hot dogs. So I can see that from the table. What if let's go up to one is $10. Offer B starts at 0. 5 hot dogs, let's see, 10 hot dogs, 20 hot dogs on table. 10 hot dogs, and then offer C, which is a combination. 10 hot dogs is 7. or $10, and then 40 hot dogs is 15. We graphed these onto a grid. So let's draw a y-axis and an x-axis. The x is the independent variable, which is number of hot dogs that we are going to sell. And this is our wage, or our income, or the amount of money that we're making. So let's put some numbers on here. So we went up to 20. So let's go 5, 10, 15, 20, 25. So 5 hot dogs, 10, 15, 20, 25. And then our 20 again. So 5, 10, 15, 20. $5, $10, $15, $20. Actually, I think I'll do my y by 2s. Get some more numbers in there. So let's go 2, 4, 6, 8, 10. 2, 4, 2, 4, 6, 8, 20. That spreads the numbers out a little bit more. Okay, so the first, no matter what. So 0 hot dogs, I make $10. 5, I make $10. 10, I make $10. 15, I make $10. So offer A is $10 regardless of how many hot dogs I sell. $10. Oops, I'm looking at $5. That's wrong. Okay, so 10 hot dogs is $5. 2, 4, 5. 20 hot dogs is $10. So this one looks like this. That's offer B. Starts at 0, 5. 2, 4, 5. 50. 2, 4, 6, about there. 20 hot dogs is $20. So this one's going up like this. And that's offer C. So we can see that they intersect at 20 hot dogs. They all make $10. So offer A was the straight salary. So 0 for the hot dogs plus $10. Offer B was straight commission. So 50 cents for each hot dog plus 0 hourly wage. And offer C was 25 cents for each hot dog plus $5. So those are the equations for each offer. And I can see that the person that makes the most money up to 20 hot dogs is offer A. Offer A makes $10. After 20, then offer B becomes the better deal. And then offer C is kind of in between. Was not very good at selling hot dogs. I might just take the $10 salary because I know I'm going to make $10 no matter what. If I'm good at selling hot dogs and I think I'm going to make or sell more than 20 hot dogs, I'll probably take offer B because that is the highest salary when we sell more than 20. Would I pick offer C? Offer C is kind of in between both. So it probably is the least attractive offer. I would either pick A or B depending on how many hot dogs that I sell. If I sell less than 20, offer C is not a bad option because I'm still going to make more than offer B. But A is better before 20 hot dogs and B is better after. And, oops, wrong way. So we can solve the system algebraically. So you know how to solve equations. So we've got one equation that's y equals 10. We've got one equation that is 50 cents for each hot dog, so 0.50x. And then we've got one equation that's 25 cents plus $5. So when we want to know when the wages are the same, we can just make two of the equations equal to each other. So I could pick the first two. When does $10 equal 0.5x? So I could divide by 0.5 to solve for x. And so 10 divided by 50 cents is 20. I could also use these two. When does 0.50x equal 0.25x plus 5? So let's combine the x's. So I'll get rid of this one here and put it over to the left side, which leaves me with 0.25x equals 5. And then divide by 0.25. Let's put that here. So 5 divided by 0.5 is also 20. So it doesn't matter which two equations I use. I just make two of them equal to each other, and then I can solve for x. Once you find the value for x, you can then find the y value by substituting back into the third equation. So let's say we used the first two equations. I could find y by putting it back into the third equation. So 0.25 times 20 plus 5 is $5 plus $5 is $10. And that gives me my salary. So my conclusion would be, when we sell 20 hot dogs, all offers make the same amount of money, which is $10. If hot dogs. So I might say, if I'm not good at selling hot dogs, I would pick offer A, where I'm going to make $10 no matter what. If I'm good at selling hot dogs, and I think I'll sell more than 20 in an hour, I would probably pick offer B. Because I'll make more money that way. Okay, here we have an example of renting a car. So one company charges $50 for the day, no matter how many miles that you drive or kilometers. And plan B is $35 for the day, but you have to pay for the kilometers. So 6 cents for each kilometer. So we want to know which is the better deal, and how do we know? So let's do a table of values. So I've got my x variable is the number of kilometers I'm going to drive, and my y is the total cost. So plan A, we'll do this as plan A. It's going to cost $50 no matter how many kilometers that I drive. So it's always going to be $50. Plan B is going to be 35 plus the kilometers. So if I drive 0 kilometers, I'm still going to get charged $35. If I drive 50 kilometers at 6 cents, that's an extra $3 plus the 35, so that's 38. If I drive 100 kilometers, that's an extra $6, so 41. And it's just going to increase by $3 every 50 kilometers I drive. So again, from the table, I can see that at 250 kilometers, both plans cost $50. If I drive more than 50 or 250 kilometers, then plan A is going to be cheaper. If I drive less than 250 kilometers, then plan B is cheaper. On the side, I probably want to increase by 6 cents per kilometer. So 100 kilometers, 200 cost me, and 300 cost. So if we plotted these on a grid, so this is number of kilometers that I'm going to drive, and this is my cost. So I'll make each of these grids on the bottom 50 kilometers, and then up to 60, so 10, 20, 30, 40, 50, 60. This is in dollars. So plan A is $50 no matter what. Plan B was $35, and then it's going to me $41. So that's approximately there. 47, that's approximately there. 250 cost me $50, and me 53, which is approximately there. So here is plan B. So the intersection point, which is 250 kilometers, cost $50. So both plans cost $50 when we drive 250 kilometers. If you were traveling less than 250, you would pick plan B. It's the lower line. If you plan on traveling more than 250 kilometers, you would pick plan A, which would be the lower line after. So this intersection point is 250-50. So I can see that plan B is lower before that, and then plan A is the lower line after that. Oops. So let's write an equation for each plan. So plan A, remember these are linear, mx plus b. So m being the rate and b being the initial value. So plan A had an initial value of $50, but there was no charge for the kilometers. So x equals number of kilometers and y equals cost. Plan B had a cost of 6 cents per kilometer plus an initial cost of 35. So you could solve them algebraically by making the two equal. I want to know when are they equal. Don't really need this 0x. So I'm going to get rid of this 35 by subtracting. We do the opposite. We do the same on the other side. That leaves me with 15. And then if we want to find x, we're going to divide by 0.06. And x equals 250. So you could solve it algebraically instead of using a table or graphing it. Algebraically is the most accurate way. And then we want to find y. Well, we know y is 50. If we sub it into this one, we would have 0 times 250 plus 50. So y is $50. You could also sub it into the plan B equation and find that solution. Okay, so